If you've been watching our series about our 1982 CJ7 behind us, you'll remember that in part 1 we pulled the engine out of the CJ, and in part 2 we did a full teardown. Now this is a 4-litre engine that you would find in a Jeep Wrangler or a Jeep XJ. We sent the parts out to Hurley Engine Services to have them machined, and we've now got them back. My block over there I have painted. My head still needs to be painted, but it is ready for assembly. I have my rods and my new pistons over here and my crankshaft. So today what we're going to do is reassemble this engine. So as I assemble the engine, I'm going to need some lubrication on the metal parts, and what I'm going to use is the same oil that I'm going to do my run-in with, and I've put it in this little oiler over here, so I'll use that to coat the parts as I assemble the engine. So in order to assemble this engine, we're going to do more or less the reverse of what we did during our teardown video. Now if you haven't watched the teardown video, maybe a good place for you to start is go and have a look at how we got to this point. First thing we're going to do is install our camshaft, which is going to go inside of over there, and then we're going to put our pistons and crank back in again, and we'll flip the engine over and do the top end. So we'll get started by doing our camshaft. We've decided to replace the camshaft. The old camshaft had clear signs of wear on the lobes over here. So we're going to put this new camshaft in, and we've decided just to go with a stock replacement. So this is just a stock camshaft. We have not upgraded the camshaft. We did actually purchase an upgraded camshaft, but found that the timing on that was very long overlap with long valve openings, and I decided that that was not our best move to go forward. So we're just going to stick with the original camshaft that came with the 4.0 engine. With the camshaft now installed, we're going to go ahead and torque these bolts. The service manual says to torque them to 18 foot-pound, so we're just going to make sure that they're nice and tight. Good, on to the next thing. The next thing we're going to do is install all the main bearings as well as the rear main oil seal over there, and once that's in, then we will put the crank into the block. Just something to note when you're installing the main bearings, there is this little pin on this side, or little cutout on this side, that you need to make sure that you get the little wedge part of the bearing into that. And the reason is that on this side there is the oil port, and you want to make sure that that hole in the bearing aligns with the oil port. Also make sure that this bearing over here is the one that controls the lateral force on the crankshaft. So it's actually got wear linings on this side, and so you need a slightly different bearing in that location. But it also has that same pin over there, so make sure that you get that correct. We now have all the bearings in. What we're going to do is bring the crankshaft next and lay the crankshaft in, and then we're going to use a little Plastigage to make sure that the gap between the bearing and the crankshaft is correct. Right, with the rear main oil seal, you need to just make sure that you get the direction correct. You will see on the oil seal there is this little V groove over there, which means that there is a lip, and you always want the lip pointing to the inside. I always think of it like this, that if there's pressure inside of here, you want that lip to open and seal. So the lip will point to the inside. We've installed the crank onto the block now, and so the next thing to do is to install the main caps onto the main bearings over here. Now before we do that, or while we're doing that, what we want to do is check. The service manual says that the clearance between the main bearings and the crank should be 0.051 of a millimeter or 0.002 of an inch. So what I want to do is I'm going to install these end caps and torque them down, but while I'm doing that I'm going to install a Plastigage. And a Plastigage is this little thin plastic wire that's sticking out over there, and we will place it onto the crank, and then we'll torque the cap down. Once we've torqued the cap down, we will take the cap off, and then we will go and look at the deformation of that piece of plastic and make sure that the clearance between the bearing and the crank is actually at the required specifications. So we're going to go ahead and do that next.
So you'll see we've installed the caps for all of the main bearings except bearing number 3. The service manual says that you need to install the caps of 1, 2, 4, 5, 6 and 7 and torque them up in 3 steps of 40 foot-pounds, 70 foot-pounds and then up to 80 foot-pounds. Once you've done that, you're going to do this third bearing cap as the last step, where you will do the same thing, but you're going to make sure that there is some movement on the crankshaft. So what I'm going to do is to first do these in the 3 steps that are required, and then once that's done, I'll take them back out again and have a look at what that plastic gauge looks like. Right, so we have our torque wrench now set to 70 foot-pounds. We're going to go ahead and do these all up to 70 foot-pounds. Right, now the torque wrench is set to 80 foot-pounds and we're going to go through the same exercise. Right, so with all of these bolts torqued now, we can now go ahead and back them off, and we'll just use the breaker bar to back them off, and then we can go and check the plastic gauges and read what the plastic gauges say. So what's happened as we had torqued those main bearing caps down is that that little plastic wire that we put in has now crushed. And what you do is you use this little gauge over here, and we're going to now measure how thick this little wire is. And it is about 0.0015 of an inch, which is on the tight side of the tolerance. You're allowed to go down to 0.001, but we can definitely see it is narrower than the 0.001 measurement. So we're somewhere between 0.0015 and 0.001, which is within spec for this engine. So this bearing cap is good, and we're going to go on now and check each one of them all the way down. Right, so we have checked all of these bearings with our plastic gauges. This one over here is the loosest one. It's at exactly 0.002, which is the target that we were supposed to achieve. All the others are slightly tighter at between 0.001 and 0.0015, which is all still within target. So I'm happy that we're okay on the main bearings. I'm going to clean the plastic gauges off now and then go ahead and reinstall the main caps and torque them down following the same procedure. Right, so the service manual requires us to check the end play of the crankshaft. So in order to do that, I have got my dial gauge over here. It's connected to the crank over there, and the magnetic base is attached to the block. What I'm going to do is I'm going to take my pry bar, and I'm going to install my pry bar over there, and then I'm going to pry the crank to get it to move. And you'll see that as I get it to move, the needle on the dial indicator moves. So I'm reading that as 0.1 of a millimeter. Our service manual says that the ideal is between 0.05 and 0.06 millimeter. So it is a little bit outside of that, but the acceptable end play is between 0.038 and 0.165 of a millimeter. So we're still well within the acceptable end play. A little bit loose, but not of any concern. So we're good to go and continue assembling this engine. Right, for the rear cap, we followed the service manual and applied a small bead of silicone over there where it dictates. And then now that that's in place, we're going to install our cap. And as you know, we have checked this cap to make sure that the clearance on the bearing is good using our plastic gauge. So we are good to go and install this cap next. What we're going to do now is install our piston rings onto our piston. Now the first thing I've done is made a clean workplace over here by putting some paper down just to make sure none of the shavings on my workbench get into where I'm working. You'll see that we have our first ring over there, the second ring, and then these two together make our third ring. So our piston has been oversized to a 30 thousandths over, and that's because we had to bore and hone our cylinders out to get that. You'll also note that the oil ring has a direction. The edges of the oil ring on the split over here need to be pointing upwards when we install them, so that's just a note so that I don't forget that. And then here on the second oil ring there's an orientation, there's a little dot. That little dot needs to point upwards, so this ring must go on in this orientation, and you won't be able to see it on the camera, but the inside of this has got a different geometry, so there's a top and a bottom. So we're going to go ahead now and install our rings onto our pistons. Right, so we've installed the rings on the first piston. You can see that they're loose there in their gaps and still able to rotate. So when we actually install this, we will squeeze them and close up that gap over here. Now this gap has been checked by Hurley before we install them to make sure that we've got the correct gap. And then as we install them, we will make sure that we offset the gaps here and here so that they're not aligned in a straight line, but offset for sealing, and we'll do that when we install the pistons. But for now, we've got our rings on our first piston. We're going to go ahead now and do the rest of the pistons. Now that we have the rings on the piston, we need to orientate them according to the service manual. So the service manual begins with this bottom oil ring and dictates that the split needs to be above the pin over here. Then the spacer needs to be at the piston skirt, etc. And we're going to follow this layout as determined by the service manual. Once we've got the gaps all in the correct position, we're going to use our ring squeezer over here, and we're going to actually compress the rings, and then we're going to drop them in. You will note that I have put this piece of hose over the bolts here as per the recommendation in the service manual, so you don't scratch the bore of the cylinder as we put it down. And it's also important to see that they have a front and a back, so this arrow needs to point towards the front of the block as we put it in. So we're going to go ahead now and set these pistons in. Right, exactly like we did with the main bearings, we're going to install our little Plastigage over there, and we're going to install our cap, and then we're going to torque these down, remove them, and check that that Plastigage has deformed and measure how much it has deformed. So I'm going to go ahead now, torque this bearing cap down, and then I'll take it off and check the Plastigage. So as you can see, the Plastigage has now deformed. The service manual requires a clearance of 0.001 to 0.003 of an inch. So if we put the gauge over there and we measure that, you will see we're at about 0.0015 of an inch, which is actually in the preferred band for this rod end clearance. So this rod end is good, and we're going to carry on now, remove the remaining Plastigage, and then torque this cap back down again, and then move on to the next one and follow the same process until we have checked the clearance on all of the rod ends and installed them.
While installing piston 6, things went horribly wrong. As I was tapping the piston into the bore, there was a thud, and the piston did not slide into the block. I removed it and found the oil ring was bent. Although the video quality isn't great, you can see that the ring slipped out of the compressor before it entered the bore, and then I gave it a tap, causing it to bend.
So what I've got over here is the bent oil ring, and one that's still in its correct original shape. If I put the two on top of each other there, you can clearly see that this piece here sticks out over there. Now I have tried to tweak this oil ring as best I can here and adjust it to try and get this bend correct,
but no matter what I do, I can't get it back into a round shape again. If I go and install this inside of the cylinder, you'll actually be able to see that it makes an opening on this edge over here. Alright, so if you have a look, you'll see that this bent oil ring does not contact the side of the cylinder wall correctly. You can see all the way through to the underside over there. So I don't think we'll be able to use this oil ring. So while we're rotating the crank to install the rest of the pistons, we noticed that this piston over here came up well proud of the top of the block. Now we haven't milled this block down significantly at all, and when we installed the other piston we noticed that it did exactly the same. So if I rotate the crank now, you'll see that this piston comes up proud of the top of the block. The problem is that this engine design has no provision for the piston moving above the top of the block. So there is definitely something wrong. This cannot fit back together again. If we put the head on, it would rest over here, and it would actually be a gap between the block. So there is actually no way that we will be able to put this engine back together again. So we need to go and investigate why this is happening, to make sure that we understand what has gone wrong. There are only three things that can contribute to this issue. It is either the piston, which has a taller distance from the pin to the top of the head, or the connecting rod, or it is the crank itself. So I'm going to go ahead and just check all three of those and then make a decision as to what's wrong. So the first thing that we can very easily eliminate is the use of the wrong rods. You'll see that this has the number 6 inscribed on there, as well as the arrow which points to the front of the engine over there. And if you've been watching the series where we've torn this engine down, I actually inscribed these marks on my rods. So I am sure that we are using the correct rods. These are the original rods that came with the engine. Right, so the next thing that it could be is the distance from the head of the piston to the center of the pin over there. Now I've gone ahead and measured this, which is the old piston, and that distance to the center of the pin there and this distance to the center of this pin over here is exactly the same. So there's no height difference between the center of the pin and the top of the head of the piston. So we know that the new piston is exactly the same as the old one. So it's not the rod, it's not the piston. The only thing that can be left is the crank. So first thing I'm going to do is measure the stroke of the piston. The stroke is how far it moves up and down. So I've measured the distance here from the top of the head to the top of the piston, which is 5.2 millimeters. Next thing I'm going to do now is rotate the crank and get this piston down to the bottom so that I can measure how far it has moved. Okay, so the piston is now at the bottom of the stroke. I'm going to go ahead and use my vernier over here and just measure this distance here. Right, so I quickly added up my numbers. I had that the piston was sticking out 5.2 millimeters above the top of the block. I measured that it went down 93.6 millimeters, giving me a total of 98.8 millimeters. The stock should be at 86.69 millimeters. If I convert that to inches, I'm at 3.89 inches. And the 4.2 has a stroke of 3.895 inches. The original 4-liter engine should be at 3.413 inches of stroke. So I am 100% sure that we have a 4.2-liter crankshaft in that block. So I'm going to need to go and speak to the guys at Hurley Engine Service and see if they have a 4-liter crank for me, or alternatively if they can press my pistons onto the 4.2-liter rods for me. Either way, we're going to need to get that fixed, because I will not be able to continue putting this engine together until I either have the correct crank or shorter rods.
Subscribe to the shop and be sure to join us for part 5, where we get the correct crankshaft and resolve the bent ring and piston installation issue.